Hello, Math 126 fans. Here we're going to talk about the test prep that we did last week on Chapter 12. Again, this was something new. I had the TAs bring copies of 2 pages of an old exam. This was the spring 2023 exam. In these videos, I'm not trying to do full solution, just trying to make some comments. So check out the full solutions. I will post them here in a moment, but this is directly from this old exam. So you can use that for practice. The real intention here was to get you to reflect a little bit on where you're at, because I just want to catch you before, UW is a competitive place. A lot of students want to do well. Some students sort of don't, when they study, they don't prepare in a way that really checks if they're ready. So I'm trying to make this happen in quiz section for you, meaning I want you to look at this and ask yourself, could I start it? And so you really have to say, I'm not going to look anything up. I'm just going to say, would I know what to do? You got to really put yourself on the spot. And if there's a hesitation in your mind, you think, where am I stuck? If you do have an idea, think about what the first thing is you're going to write. And that's really an important step in any of your studying, in any of your courses. Are you going to be able to actually do something? Do you have a sense of what so sometimes you get this false sense of, I understand what he's doing, or I understand what the solutions are saying, but that's still not the same. And that's personal, this learning piece. Like, I am confident and know what to do. Okay, so we had a question about naming. If X was fixed, if X is fixed, what do you get? So we're saying if there's a constant here, what is that? We can immediately say it's a parabola, because one of them squared and the other one is not. And we talked about this naming of, similarly, if y is fixed, it's a parabola. So right away we know it's a paraboloid, because in 2 directions it's a parabola. And then lastly, what happens if we fix z? It's hyperbola. So we call this a hyperbolic paraboloid. It's a Pringles chip. Drew that in a previous video. Anyways, area of this parallelogram. Now that should make us think cross product. It actually, an interesting thing about this is it doesn't matter which 2 sides. Even if you use the vector AC, it also gives you the correct area. Because that's a separate discussion. But you need AB, AC, do their cross product, find the length. So when you're done doing the cross product, AB cross AC, you need to find its length. Again, I'm going to leave you to check the solutions, check that out. But this is where I'm saying we should know, like, if you're studying and you didn't know cross product, find the length, that's a problem. You need to add that to your list. Find the vector of length 5 that points in the same direction as BD. This is a rescaling question. If you didn't immediately think rescaling, make a note of that. That's what you're looking for when you're studying. You find the vector BD, make it a unit vector, multiply times 5. That should be our immediate thoughts. The line segment BE shown is perpendicular to AD. Find the length of that segment. That's a projection question. If you didn't immediately think projection, then add that to something you want me to ask me about in office hours, discussion board, ask in quiz section. That's what you're trying to do when you're doing this sort of studying, is figure out what you need to add to your understanding. Okay? You can't go into the test and say, I'm going to look everything up on my note sheet. You need to have a little bit of, I know how to start most things. That's really the big difference between those that do well and those that don't. Students that do well know how to start all the questions. They've prepared enough that they know how to start all the questions, and they're good at the details and good at checking their work. But the part about being prepared, you can do that as well. Okay, so I want to project AB onto AD. So I already have a plan of attack. I'm going to do AB dot AD and divide by the length of the ground. So first I'll find those vectors and I'll compute. So that's a good example of a little bit of practice. I think all of those are named things. So we should be ready for that. Okay, what about this one? These problems scare students a little bit, so it's good to kind of prepare. This would never be worth very much, but it is good to have a few examples in your head from when you did this in the homework. Best thing to do is look around the room you're in. The two planes are always parallel or intersecting. That's true. So this should get you thinking about, for lines, we had parallel, we had intersecting, and we had this other one which we called skew. So for lines, you can have parallel, intersect, or skew. But for planes, they're either parallel or they have to hit at some point. Two planes are always parallel intersecting. That's true. Two planes perpendicular to a given plane must be parallel. Now this one I've gotten, well, the first time I ever saw this problem, I think I thought of it incorrectly and I got it wrong because I drew a picture like this. This is an example of trying to draw something to prove it's true. In general, in math, we're trying to draw something to prove it's false, a counterexample, because we're done, or we're trying to prove it. So if you look at it like that, you're like, oh yeah, but if you turn one of these in any sort of way, then that's not true. You can look around the room you're in and see examples. My first example I always look at is the corner of the room. This is perpendicular to the ground. This is perpendicular to the ground. They are not parallel to each other. So that's got to be false. Okay. So that's this piece that students maybe are kind of new to, but it's nice to have a collection of basic examples if you're worried about a problem like that. You're always trying to think about, is this something we know to be true from the things we know? Or is this something where there's an obvious example where it's false? Those are your first two initial thoughts. If neither one of those leads you to an answer, then you might have to do an example, and that takes longer. Okay, consider the line that contains the point and is orthogonal to the plane. Oh, that's a nice question for us. Why do I say that? As soon as there's mention of a plane, this is what I draw. Let me move this up so you can see it. And I draw a vector pointing straight out of it. 0, 3, -4, 0, because there's no x. Consider the line that contains the point 5, 0, 0, and it's orthogonal to the plane. So I'm going to draw this line. It goes through the point 5, 0, 0. I don't know if that's on the plane or not. It didn't say. So this is a question about finding a line. So immediately I would be, that's the thing I don't know is the line. I knew the plane already. I'd be writing this. Step 1. I would look for a point on the line. They told me that. Step 2. And then I'd look for a vector that points this way. Well, I have one. This is one of our happy situations. And then finally, what does it ask me to do with this? Find the 2 points of intersection of this with this. So we're going to substitute. Substitute that in for x. Substitute that in for y. Substitute that in for z. And I think it simplifies dramatically. That gives you t, and there's your answer. All right, so we should have had a plan of attack of what did we not know here? What we didn't know was the line. Oh, I gave a hint there too. Find the equation for the plane that passes through this point. So now we're looking for a plane that passes through this point. So we immediately can write that. And contains the line of intersection. Okay, so it contains a line. And I mentioned in class that the moment you see the line of intersection of two planes, that's a particular kind of important type of example. And there's a couple different approaches to it, which leads to confusion, because if you're watching the video in the textbook, they might do something different than I do, which is fine. But I told you one plan that is usually a good strategy in such a problem is to combine and find 2 points. Most of the time in these problems, you have to find 1 point, and my philosophy is I have to find one, I might as well find a second. So we're going to take one, substitute into the other, because there's 3 variables in both. And maybe I could guess an answer now, but I'm not sure. I'm going to solve for y because it looks like the easiest to plug in. You can also subtract them side by side. I just don't know everyone's background. I'm going to shove this in here, and then we've got it. Meaning 2x plus 1 minus x plus z minus 3z is negative 1, is equal to negative 1. The goal of that is to simplify this into a form that I can guess the answer. So I'm going to drop the parentheses. I'm going to get 1 plus x minus 2z is negative 1. And so that means x minus 2z is negative 2. And now I can find points till my heart's content, meaning I could have z be 0, then x has to be negative 2. And if x is negative 2 and this is 0, this is going to be 3. Now, I don't really trust myself, so if this were a test, I definitely would stop for a moment and say, does this work? Meaning, I would do negative 3, negative 2, 3, 0. Do I get 1? Yep. And then I would do negative 2, 3, 0. To me, on a test, it's very worth your while to do that, because then you can have confidence moving forward. Success. So that's 1 point. So at this point, you can kind of stop and assess where you're at. Actually, I'll call that point B. Call the initial point point A. Now we have 2 points. You kind of stop here for a second and say, I'm kind of lost in what we're doing. Well, we're trying to find a normal. They didn't give me a normal. So we're leading towards doing a cross product. But in order to do the cross product, we need a couple vectors on my plane. So we have one now. We can get the vector AB by subtracting. And that will give me one vector. Now I need a second. So if you're following my general strategy, you would just find a second point. There's another way to do it, which is you could do a cross product of the normals, and that will also point in that direction. That'll give me a second vector. But let's just get a second point, since that's what I've been doing in class. You could say, well, I'm going to have x be 0. That means z has to be 1. And that means y has to be 2. So now I can get AC, or whatever I want, BC, do their cross product, I'm done. Okay, so I hope that gives you a plan of attack. Read those solutions, look through more old exams. The point of this, I hope this was helpful to you, was to get that reflection. I read through several students' reflections, and there were all a variety of different things people said. But I hope this, got you thinking about what an exam might be like. All right.